Hi, this is chapter 20 and 21 about standard error percentage. So here's the first example. A college has 25,000 students and 15,000 of those are older than 22. And suppose that we take a simple random sample of 900 students. The idea here is that we know about the composition of the entire population, and we want to know what we can say about the sample, a smaller sample of those students. First question is we're going to find out what is the expected value for the number of students that appear in our sample who are older than 22. And we also want to know about the standard error associated with that sample. So this is the easy problem. It turns out that the percentage of the sample should reflect the population. So because the population percentage is 15,000 out of 25,000, which is 60%, the sample that we collect should also have the same expected average. In other words, 60% of 900 is 540. So we expect that there should be 540, again approximately 540 students who are 22 or older. And now we want to know about the error of this estimate. And to do that, we use the box model. And so this is a box of 1 and zeros, right? 15,000 ones and 10,000 zeros. And so the SD for the box is big minus small, so 1 minus 0. Square root of the percentage of the big is 60%, so that's 0.6. The percentage of the small is 0.4. Square root of that, so you get 0.5. This is the SD of the box. To get the SE, or the standard error, we just multiply the SD with the square root of the size of our sample. So in this case, root of 900, so that's 30. 30 times 0.5 is 15. So this is the error that we expect to get. So that means that if we picked out 900 students, we expect to get about 540 who are older than 22, and that error is about 15. Right? The SE is very similar to the SD from chapter 5. Part B, so basically this is about the number of students. If we want to know about the percentage of students, it's actually only a small change. So we want to find the expected value in part B for the percentage of students in the sample who are older than 22. And also the standard error, but this time for the percentage. So it's actually very easy. We just take these numbers and divide by the sample size. So for example, we expect to get 540 as a number. Well, as a percentage, we expect 540 out of 900. So that's 60%. Notice this match up with the population parameter. So that's the easy one. And then how do we get the SE for percentage? We take the SE for the number, which is 15, and divide it by the sample size, which is 900. So 15 divided by 900 is 1.7%. So that means that we expect to get 60% in our sample that are 22 or older. And then our error percentage, right, again the SE in percentage is about 1.7%. So that's the example 1. This is chapter 20. In chapter 21, we basically do the reverse of this. In other words, we don't know anything about the sample, the population. We don't know anything about the composition of the population, and we're going to pick our sample, and we're going to measure the statistic from the sample, and then from that we can infer something about the population. Right? Once again, this example 1, we have the information about the population, and we want to say something about the sample. In chapter 21, we're going to take the sample and then use that to deduce something about the population. So here's an example. Say we do another simple random sample of 400 persons, and this time from a group of 100,000 voters in a certain town, and say that we want to know how many of those people are independents. And say that our sample 400, right, 300 of those people happen to be independents. So notice again, the difference here is that we don't know anything about the population, but we can count the sample, and then the samples can help us understand something about the population. And we also want to know about this 95% confidence interval, so we'll get to that in a second. So again, from the sample, since we got 300 out of 400 is 75%, so that means that our sample is 75%. So we're going to use that sample to infer that the population parameter, the number of independents from the entire population, is also 75%. And then to find the the standard error for the sample percentage, you want to know what this error is, we're going to use something called the bootstrap method. And the reason why we have to do this is because to find the SE, we need to know the SD of the box. And in the SD formula of the box, we need to know the fraction of the big number times the fraction of the small number. And the problem with this is that we actually don't know these fractions because we're trying to learn something about these fractions from our sample. We don't know anything about these total population voters, so we can't really compute this SD number. So the bootstrap method is a way to get around this. We're going to estimate these numbers by using our sample. So this is kind of going around in a circle a little bit, but turns out in practice this works fairly well. And so again, the problem is that we don't have the data for the population. So we're going to use the percentage from the sample to estimate the population percentage. So to get the SD of the box, we're going to estimate the fraction of the big to be 75%. That's what we found out from the sample. The fraction of small is 25%. These are the independent. These are not independent. If you do that, the SD of the box is approximate to be 0.43. And then from now we can use that number to get the SE of 400 draws. So again, the formula is, as you see from the previous problem, you take the SD of the box, you multiply by the square root of the sample size. So this is 20 times 0.43 is about 8.66. That's the standard error for the number of independent. To get the percentage, you take that number and divide it by the sample size, which is 400, so you get about 2.2%. So that means that if we pick a sample of 300 and we found out 75% are independent, we infer that the population is probably going to be about 75% independent, and the error of our estimate is about 2.2%. So this is an example of where we use surveys to deduce something about the total population. And the final question is, we want to come up with an interval of confidence. We want to find a 95% confidence interval for the percentage of independents. So the way we do that is that we treat this as a normal distribution. 95% confidence interval, you remember from chapter 5, is 2 SD away from the average. So in this case, we're going to say 2 SEs away from the expected percentage. So the expected percentage is 75%. The SE is 2.2%. So we want plus 2 times 2.2 and then minus 2 times 2.2. That will be our interval. So 75% plus or minus 2 times the SE is 4.4%. When you add a minus, you get an interval from 70.6% to 79.4%. That means that we can say with 95% confidence that our percentage of independent from the population lies between 70 to 79%. And so this is an example of using the sample to get information about the total population. So this is chapter 20 and 21.